All right, let's look at the homework 16.4, problem number 1. All right, so let's look at part A, part 1. All right, so it looks like x is equal to 4 cosine of t. If you want to find dx, all you have to do is take the derivative of that, so which is going to be 4 sine of t, actually negative. Right, so it's going to be negative 4 sine of t. All right, dy is going to be derivative of that is 4 cosine of t. All right, dt. All right, let's submit for a test. Oops. All right, I came back and looks like we got this one correctly. All right, let's look at the part 2. All right, so we want to rewrite this line integral in terms of t. Right, so we have x is 4 cosine of t minus 4 sine of t, and dx we have a negative 4 sine of t. Right, x is 4 cosine of t, y is 4 sine of t, and dy is 4 cosine of t dt. Right, then what they do is we can just distribute this sine of t over here, sine of t over there, and simplify. Right, so let's do that. So let's fill in the detail. So I'm gonna actually just go down here so that I have more room. All right, so it's an integral from 0 to 2 pi. Right, then I'm going to distribute this guy to each term. All right, so we're going to get, it's going to be negative 4 times 4 is 16. All right, we have a sine times cosine, so sine of t times cosine of t. And next one is negative 4 times negative 4 is positive 16. Then you have a sine squared of t. Right? And here we do the same thing. We're going to distribute full cosine of t to both of these terms, right? So we're going to get positive 16 cosine squared of t, and plus 4 times 16 again. Then you have a sine of t cosine of t, right? Then we have dt. Right? So we can see that we can cancel negative 16 sine of t times cosine of t. There's a positive of the same thing, so we have that. And we have a 16 sine squared, we already have it. And then you have a 16 cosine squared. So we're going to put the cosine squared of t, right? Then after that, since you can pull out 16, then you have a sine square plus cosine square. It is going to be 1, so it's going to be 16 there. All right, so we're going to have, so this is cosine squared of t, and here you're just going to get 16. All right, let's submit. All right, I came back and looks like we got this one correctly. All right, let's look at the part 3. All right, so we just have to integrate 16 from 0 to 2 pi. So you get the antiderivative 16t from 0 to 2 pi, and plug it in. You can see that the 16 times 2 pi is going to be 32 pi, and minus 0, so it's 32 pi. All right, let's submit. All right, it came back and looks like we got part 3 correctly. All right, so let's look at the part B. All right, so I'm gonna click to begin. All right, so for this one, we have to use the Green's theorem, and according to Green's theorem, we're gonna have a partial of Q right here, minus partial of P right there. All right, so let's submit. All right, it came back and looks like we got the part 1 correctly. All right, let's look at the part 2. Part 2 is a partial derivative of Q with respect to x. Derivative of x is 1 and derivative of y is 0. So it's going to be, answer is 1 there. And a partial p with respect to y is going to be -1, right? Right, so we have -1. Let's check the answer. All right, it came back and looks like we got part 2 correctly. All right, so let's look at the part 3. All right, so we know that using the Green's theorem, we can turn it into this double integral, right? And over the same region, you have from 0 to 4, radius goes from 0 to 4, and it's 0 to 2 pi, right? I'm going to have to go back and read the question here. The region is going to be C is around the circle centered at the origin, and radius 4, right? So that's why we have this polar coordinate. R is going from 0 to 4, and then you have to go all the way around. So theta is going to go from 0 to 2 pi. Right, so this is an area element for the polar coordinates, r, dr, d theta. But this part it came out to be a 1 minus -1, which is just going to be 2, which is here. All right, now we can just pull out the 2, then put 2 outside there. All right, then we just have to evaluate this. All right, so you can see that the antiderivative of r is going to be r squared over 2. So if you plug in 4, so 4 squared, it would be 16 over 2, right? But when you do an integral of 1 with respect to theta, it's going to be theta. If you plug in 2 pi and a minus 0, so it's going to be 2 pi. So they cancel 2 pi 2 and over 2 cancel out. So you're just going to get the 16 times pi, right? Then we still have 2 in front. All right, so this is going to be 32 pi, which is exactly the same answer as part A. So let's submit. All right, it came back and looks like we got part 3 correctly as well. All right, that's it. I hope that this was clear.